Hello friends, today's question. Two independent harmonic oscillators of equal masses are oscillating about the origin with angular frequency omega1 and omega2 and have total energies E1 and E2 respectively. The variation of their momentum P with positions X are shown in the figure. If A upon B is equal to n square and A upon R is equal to n, then the correct equation is RR. So this might be a single correct or multi-correct question. So if this is the first harmonic oscillator, so it is oscillating in the shape of an ellipse, and the second one is having a shape of your circle. Okay. In this case, the you can say major axis A, semi minor axis B, and here the radius of circle is given as R. So it is given that the total energy is E1 and E2. So we are going to start from here. First we are going to find out the total energy, and then we are going to use the relationship between which is given as A upon B n square and A upon R is equal to n, and then we are going to solve them further. So we know that the total energy in a harmonic oscillator is given by P square upon 2m plus half m omega square x square. So in this case, this first part is the representation of the kinetic energy, and the second part is the representation of the potential energy. So here the kinetic energy is represented in the form of the momentum because P is given as momentum. Therefore we can write that P is the momentum X is the displacement from the equilibrium m is the mass, and omega is the angular frequency. So let us solve these two independently because the shape of both you can say phases are different. Okay. So let us call shape of phase trajectory shapes of phase shape trajectory. And this phase shape plot is between the momentum and the displacement. You can see this phase shape, SHPE. This phase, spelling is wrong, this is SHPE. Phase shape plot is between momentum, which is given as P, versus displacement, which is given as X. So for energy E, the shape is in the form of ellipse. Okay. So I can write that for E1, the phase shape is ellipse. and we can write the general equation of the ellipse is x square upon a square plus x square upon b square is equal to 1. Okay, but in terms of the given ellipse, one axis is given as x-axis, whereas the other axis is given as p-axis. So we are going to modify the equation of the ellipse and write in the given format. So we can write that the equation of ellipse is, this will be x square upon a square plus p square upon b square is equal to 1, and where a is our semi-major axis, and this is along x-axis, and b is our semi-minor axis, and which is along p-axis. And it is also given that a upon b is equal to n square. So we have been given that a upon b is equal to n square. So from here also we can you can say draw a conclusion that the ellipse is stretched more in x direction as compared to p direction. So from here we can say the ellipse is stretched more in x direction as compared to p direction. Same conclusion can be drawn also by looking at the figure. Okay, so we can say in the a direction it is stretched more as compared to b direction, and same thing is reflected by this given equation. Now let us do the same analysis for energy E2. So we can say for E2, the shape of phase is circle. So you can see the phase shape is a circle. So the equation of the circle, it can be written as x square upon r square, p square upon r square is equal to 1, where r is the radius of circle, r is radius of circle, and it is also given that a upon r is equal to n. Okay, from here we can say it is symmetrical about the origin. Now let us express the energy, this equation, let us call this equation number 1, in terms of A, B and R. In terms of A, B and R. Expressing energy in terms of A, B and R. So we are going to start with our E1. So we can say for E1, equation 1 becomes, so the total energy, let us suppose this is given as E, and now we can write that E will be equal to E1. Therefore we can write E1 will be equal to half m. Omega 1 is the angular frequency and the displacement is x, plus momentum is p and mass is 2m. So we can say at the extreme position of the motion, either x or p will reach their maximum value a and b respectively. Okay, so it means at extreme value, extreme position, x is going to have a maximum value of a and p is going to have maximum value of b. Okay. So you can say that at extreme of the motion, either x or p will reach their maximum value, of a or b respectively. So therefore we can write that at maximum displacement, x will be equal to a and p will be equal to 0 in one direction. Okay, so therefore we can modify this equation this E1. Let us call this now equation number 2. So we can say that from equation 2, we put p as 0 and x equal to a. So this gives us that E1 will be equal to half m omega 1 square, and this comes a square. And when we have, we can say, maximum momentum p will be equal to b and x will be equal to 0. Therefore we get that E1 will be equal to b square upon 2m. But the phase relationship, you can say phase shape relationship, is given as a by b is equal to n square. That is given in the question. So you can write, but phase shape relation is given as a by b is equal to n square. Okay, for ellipse is given. So from here we can write that b is equal to a upon n square. Okay. So therefore we can get the value of this E1 in terms of a, because here E1 is already in terms of a, and this E1 we are also going to get in terms of a by substituting b is equal to a upon n square. So therefore we can write, let us call this as, I think, equation 3 and this as equation 4. So we can say from equation 4 we get E1 is equal to a upon n square whole square upon 2m, and this comes as equal to a square upon 2m and 4. So we have now two equations for E1. This is our one equation and this is our another equation. So let me write it here. Thus we have we have E1 is equal to half m omega 1 square a square, and E1 is equal to, this is also half a square upon 2m and 4. Let us call this as equation number 5. So this is 5a and this is 5b. Similarly, we are going to solve, we can say we are going to sort it out for E2 also. Okay, and E2 is for circle. So we can say for E2, from equation 1, we get E2 will be equal to half m omega 2 square x, and this is equal to p divided by 2m. And it is given that E2, the trajectory of E2 is a circle. From the figure we can say that trajectory of E2 is a circle, which means it is symmetric in x and p. That is, it is symmetric in x and p. So once again we are going to find out maximum displacement in terms of x and maximum displacement in terms of p. Therefore, we write that at maximum displacement, we are going to have x is equal to r and p will be equal to 0. Therefore, we can write that our E2 is equal to half m omega 2 square, and this is our r square. Now at maximum momentum, x will equal to 0 and p will equal to r, because it is symmetric. Therefore, we can write that our E2 is equal to r square upon 2m. Once again, we are given that our a by b is a by r is equal to n. Okay, so we will sort it later on because it looks almost similar. So let me write it here, that now we have E2 is equal to half m omega 2 square r square, and E2 is equal to half r square upon m. So these are the two values of, let us call this equation number 6. This is a and this is our b. And we know that a upon r is equal to n. So you can write a upon r is given as n. So from here we can say that a is equal to rn. So if a is equal to rn, therefore we get that E1 will be equal to half m omega 1 square, and this becomes nr and whole square. So we can write this as half m, and this will be over n square omega 1 square and r square. And bear in mind, this is for E1 means for ellipse. Okay. So you can say for ellipse E1. Now similarly we are given that E2 is equal to our you can say, but E2 is equal to half m omega 2 square and r square. Okay, and this is for circle. So substituting, or we can say this is also r, this is also r, so we simply divide them. Okay, so we get E1 upon E2 will be equal to half m n square omega 1 square r square divided by half m, we have omega 2 square and this is r square. This half m r square goes away, and this comes equal to n square omega 1 square upon omega 2 square. So we can write it here that E1 upon E2 is equal to n square omega 1 square upon omega 2 square. And also we know that E1 is given as, so we can write here also, E1 is equal to half a square upon mn4. So we substitute a here, so we get is half a is our rn whole square divided by mn4. So this becomes half r square n square, this is mn4, and this goes by 2. So we are left with that E1 is equal to half r square divided by mn square, and E2 is given as half r square m. So we can write, but E2 is our half r square m. So therefore, simply dividing them, we can write that E1 upon E2 is equal to, this is half r square m square. So we get this as half r square mn square divided by half r square m. And in this case, half m goes away, square and square goes, and this comes as 1 upon n square. So let me write it here that E1 upon E2 is equal to 1 upon n square, and we also found out that E1 on E2 is equal to n square, omega 1 square and omega 2 square. Okay, we can say, but E1 upon E2 is equal to n square, omega 1 square and omega 2 square. So we substitute here 1 by n square. So this gives us, excuse me, 1 upon n square, omega 1 square and omega 2 square. So this becomes omega 1 square, omega 2 square is equal to n raised to power 4. So which gives us that omega 1 upon omega 2 is equal to 1 upon n square. Okay, and in the solution it's just reverse of it. So omega 2 upon omega 1 is equal to n square. Okay, this is one of the option to us, and we can also find out what will be our E1 and E2. So we are going to use this relationship. So we know that E1 upon E2 is equal to n square multiplied by omega 1 square upon omega 2 square, and n square is omega 2 upon omega 1. So this becomes omega 2 upon omega 1 multiplied by omega 1 square and omega 2 square. This goes with square and this goes with square. So we are left with this will be equal to omega 1 upon omega 2. So therefore we get that E1 upon E2 is equal to omega 1 upon omega 2, or we can say it is E1 upon omega 1 is equal to E2 upon omega 2. So we have two options that are correct. One is our omega 2 upon omega n square. That is the correct option. So this is option B. Option B. And we have E1 upon omega 1 and E2 upon omega 2. So we have option D. Okay. So this is our option D. So we have two options correct. Okay. So in this entire question, you can say it is a simple manipulation of the energies E1 and E2 in terms of maximum displacement and in terms of maximum momentum, and using these two equations, okay, substituting, making left and right and making some adjustment, we are going to get the answer. Okay, so therefore this completes the question. Thank you.